Jai Hind children, welcome to today's class. We are going to start chapter 1 sets. The set theory was developed by the German mathematician Georg Cantor. This concept is used in every branch of mathematics. In our daily life, while performing our regular works, we often come across a variety of things that occur in groups. Example, team of cricket players. Actually, it is a group. The same way, a group of tall boys. That also is a group. The word team, groups, etc. convey the idea of certain collection. Now, I am going to give a definition for well-defined collection of objects. Look at the definition. Well-defined collection of objects. If any given collection of objects is in such a way that it is possible to tell without any doubt, that is very important. If you can tell without any doubt whether the given object belongs to this collection or not, then it is called as a well-defined collection. At which we can consider an example and then can come back to the definition again. Here the definition states that if it is possible to tell without any doubt whether the given object belongs to this collection or not, I am going to consider a collection as rivers of India. Rivers of India. And going to consider two rivers as one as the Nile River and other as the river Ganga. Here I am going to check whether this collection rivers of India is the collection I am going to consider is a well-defined collection or not. If you consider the river Nile, without any doubt you can say that it does not belong to this group. And without any doubt you can say that the river Ganga belongs to this group. Thus, if you can tell whether the given object belongs to this collection without any doubt, then it is called as a well-defined collection. Now I think you get a clear idea what a well-defined collection. The members, without any doubt you can say it as a member in the given collection. Suppose you consider another collection of objects as a group of, that is also a collection, a group of pretty girls. A group of pretty girls. We can check whether this collection is a well-defined collection or not. Suppose I am going to consider the members as the students of class 11 or girls of class 11. The girls of class 11. I am sure that definitely that you will be in doubt whether a student comes or a girl comes in this group or not. Because a girl which seems to be pretty in the eye of one person may not be pretty in the eye of the other one. So, this is not a well-defined collection. Why? Because you are not sure about it, or it is not possible to tell without any doubt that the members belong to this group. So, this is what we mean with a well-defined collection of objects. Now, I will tell you why I said this definition, well-defined collection. Come to the new definition, the definition of set. Keep in memory this definition. A well-defined collection of objects is called a set. Now, you are not that what a well-defined collection is. A well-defined collection of objects is called a set. So, you can say that the rivers of India is a set. Why? Because it is a well-defined collection. But a group of pretty girls is not a well-defined collection, so it is not a set. So, in this way, a well-defined collection is called as a set. Now, I am going to say some terms or some elements regarding the term set. First of all, you try to understand that sets are usually represented by, sets are usually represented by capital letters, A, B, C, X, Y, Z, etc. But the members of the set are denoted by small letters, small a, small b, small c, small x, etc. This is the first point. Sets are usually represented by capital ABC, but the members are represented by small abc. The second point is that if small a is an element of the set V, capital V. I am going to consider a set V and I am going to consider A as an element of a set. We can say that A belongs to V, or A is an element of V. This belongs to is represented by, we can say that A belongs to V. Belongs to is represented in Greek symbol by. Greek symbol for belongs is epsilon. It is represented like this, epsilon, called as epsilon. So, A belongs to V. You can put the symbol epsilon for the word belongs to. Now, in notation, you can write A belongs to V, or you can say that A is an element of V. And the same way, you can say that B is not an element of V if it is not an element. So, these are the two symbols used to represent whether an element belongs to the set. If it is belongs, you need to write this epsilon symbol, and if it is not an element or not belongs to, you need to cut this or draw a vertical line for the epsilon symbol. So, this is the first and the foremost points you need to remember in the case of a set. Another example I am going to consider. Example. 6 is an element of the natural number set n. N is a set of natural numbers. You are clear that 6 is an element of n, but 0 is not a natural number, so you can write 0 is not an element of n. In the same way, another example, 36 is an element of P. I am going to write P being the set of perfect square numbers. P being the set of perfect square numbers. If P is the set of perfect square numbers, then clearly you can say that 36 belongs to P. But 5 is not an element of P. Why? 5 is not a perfect square. So, this epsilon symbol and not epsilon symbols are used to represent whether an element belongs to a set or not. Now, we are going to study some examples of sets used particularly in mathematics. I am going to give the notations of some important sets in mathematics. N, capital N. This set is called as the set of natural numbers. Very important. Set of natural numbers are represented by capital N. Set of natural numbers known for you as 1, 2, 3, etc. And the same way, W is the set of whole numbers. Set of whole numbers can be represented as W. W then can be written as 0, 1, 2, 3, etc. All these are elements or the members of the set. Then, another notation is Z. Z represents the set of all integers. Set of all integers. You know which are the integers. Integers can be represented as etc. -3, -2, -1, 0, 1, 2, 3, etc. Now, at another symbol Q. Q is used to represent the set of all rational numbers. Set of all rationals. You know what a rational number is? Numbers of the form P by Q. For example, -3 by 4, -2 by 3, -1 by 2, +1 by 2. All are rationals that we can consider the set of rationals. Now, at another one, capital R. Capital R means the set of all real numbers. Set of all reals. You know that a real number means the set of rationals and irrationals. Rationals and irrationals together called a set of reals. Now, some special sets. Z plus. Z plus means that a set of Z is set of integers. Z plus means set of positive integers only. Set of positive integers. That is set 1, 2, 3, etc. In the same way, Q is the set of rationals. If I write as Q plus, it will be set of positive rationals only. Positive rationals. And the same way, R known as the set of reals. So, R plus represents the set of positive real numbers. So, these are the notations for or the famous sets particularly used in mathematics. N natural numbers, W whole numbers, Z set of integers, Q set of rationals, R set of reals, Z plus set of positive integers, Q plus set of positive rationals, and R plus set of positive real numbers. Note that object, elements and members all are synonymous terms in the case of a set. Now we can study a representation of sets. Sets are generally represented by two ways. The first method is a roster or tabular form, and the second method is set builder form. We are going to represent the sets by means of these two methods. Okay, at first we can come to the roster form or tabular form. Listen to this. In roster form or tabular form, in this form, all the elements of a set are listed. The elements are being separated by commas and are enclosed within the curly braces. What we need to do that? You need to list the elements or you need to find out the elements of the set. And the elements you need to write in curly braces by putting commas in between. Let us come to an example at first, then can come to the definition again. Example 1. The set of all natural numbers less than 10. We need to write the set of all natural numbers less than 10 in roster form. I already told you that sets are usually represented with the capital letters A, B, C, etc. I am going to write it as capital A equal to. As we need to write the elements in a roster form, the method is you need to put curly braces for to list the elements. What is the question? The set of all natural numbers. You need to write all natural numbers, but the condition is that it is less than 10. Which are the natural numbers which are less than 10? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Because it is less than 10, so now I need to take the number 10. So, this is the method of representing the set in roster or tabular form. The method is write the elements within the curly braces by putting commas in between the elements. Come to the second example. The set of prime natural numbers. I am going to write the set B equal to. I need to write the set of prime natural numbers. Natural numbers must be natural numbers, but that must be prime. Okay, I am going to write by opening the curly braces. We know that 1 is neither prime nor composite. So, the next prime number will be 2, 3, 5, 7, 11. We know that, etc. Because the list continues. Here, the list continues indefinitely. Here, the list continues indefinitely. We will study about the nature of this type of set later. Anyway, try to understand to write the elements in the roster form. Read the question. Write the elements which are favorable for the given condition in the question. Write the elements in the curly braces separated by commas. Okay, now we can come to the definition again. In this roster form, all the elements of a set are listed. All the elements are listed. Listed means you need to write down. The elements are being separated by commas. Each element should be separated by commas and are enclosed within the curly braces. So this is the method for to write the set in roster form. Okay. Come with a note. In a roster form, order in which the elements are listed is not important. The order of the elements is not important. Means that if you write a set in the order as, for example, the first set is writing the set of all natural numbers less than 10 as 1, 2, 3, 4, 5, 6, 7, 8, 9. The order of these elements is not important. If you are asked to write the set of all natural numbers less than 10. Less than 10, you can write it in any order. You can write the set like this also. 2, 5, 1, 3, 8, 7, 6, 9. So, in any way you can write. But the one more element, 4. Okay. Anyway, the order of the elements is of no importance in the case of a roster form. And the second property is that in a roster form, an element is not repeated. Very important. An element should not repeat. That is, all the elements are distinct. Distinct means different. For example, I am going to consider a set in which the set of letters forming the word miscellaneous. 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 I need to write the set of letters forming the word miscellaneous in a roster form. How we can write this? We will write as set as A equal to, opening the braces. The first element is M separated with the next element I. The next one is S. The next one is C. The next element is E. The next element is L. Again an L, but the element should not be repeated. So no need to write the next L. Then comes with the element A. Then comes with the element N. Then again an E. No need to write this. Why? Because the element should not repeat it. Then O. Then comes with the U. Then again comes with an H. No need to write because it's already in this set. So this is the list of letters forming the word miscellaneous. MISCELLANEOU. Why? Because The elements should not repeated when writing in a roster form. So these are the very two important properties of a roster form. That the first is that you can write the element in any order, and the second one is that the set of letters or the set of elements should not be repeated. Now we are going to discuss some questions based on the roster form. The first question is, write the solution set of the equation x square plus x minus 2 in a roster form. We are asked to write the solution set of this equation in a roster form. Okay, at first we can write the solution set. We have x square plus x minus 2 equal to 0 is the given equation. For to find the solution, you can use any method. I am going to use the splitting the middle term method as x minus 1 into x plus 2 equal to 0. Why? Because summing up you need to get plus 1 and product you need to get minus 2. From this I can say x minus 1 equal to 0 or x plus 2 equal to 0. From this I will get two values, x equal to plus 1 and x equals minus 2. These are the two values. We are asked to write the solution set of this equation in the roster form. How to write the in roster form? Therefore, the solution set of the equation in a roster form is how to write the solution set? You have to open a braces, write the elements by listing the elements by putting a comma in between. So this is the representation of the solution set in a roster form. So that's the first question. Come with the problem 2. Write the set in a roster form. A set is given for you. Set of all x. We need to read like this. Set of all x such that this column represents such that x is a positive integer. The condition is that x should be a positive integer, but the square of that number must be less than 40. You need to write only positive integers, but the condition is that the square of that number should be less than 40. Two conditions are given for you. So at first you need to write the elements in a roster form. The elements in a roster form are a roster form is, okay, I am going to write the first element is 1. Is it a positive integer? Yes. Is the square of that number less than 40? Yes. Okay. I am going to write the second number 2. It is also a positive integer. Its square is less than 40. 3. It is favorable because 3 square is less than 40. 4. That also favorable because 4 square 16 is less than 40. 5 square is 25 which is less than 40. 6 square is 36 which is less than 40. But 7 square is 49 which is not less than 40. So these are the only elements favorable for the given set. So writing the set in roster form means that writing the elements favorable for the given condition in the question by putting commas in between and enclosing them in curly braces. Okay, come with problem 3. List all the elements of the set. A equals set of all x such that x is an integer, but the condition given is that minus 1 by 2 less than x less than 9 by 2. Two conditions are given in the question. You need to write all the elements in a roster form. All the elements in a roster form. How we can write? At first we can write the set. What is given for you? Given x is an integer. Also, one more condition given to you that minus 1 by 2 less than x less than 9 by 2. What do you mean with it? Minus 1 by 2 less than x less than 9 by 2 means that what is minus 1 by 2? Minus 1 by 2 means minus 0.5. Less than x less than 9 by 2 means 4.5. So this seems to be easy for you to find out the elements. But the condition given is that x is an integer. Can you say which are the integer values which lies between minus 0.5 and plus 4.5? The integer values, therefore, the required numbers or the required elements are. The required elements are. Which are the numbers favorable for this condition? So, between minus 0.5 and plus 4.5, the numbers can be 0. Then, which number will come? 1. Then comes with a 2. Then comes with a 3. Then 4. We can't take more than 4. Why? Because up to 4.5, all the integers you need to take. Between minus 0.5 and plus 4.5, all the integers you need to take into account. So, the numbers are 0, 1, 2, 3, 4, etc. Actually, this is the required set. So, we can write to represent it as A equals set 0, 1, 2, 3, 4. Come with one more problem. Problem 4. Write the following set in a roster form. We are given with a set V equal to set of all x such that x is an integer and x plus 1 equal to 1. Two conditions are given for you. Can you say x plus 1 equal to 1 is favorable with which element? Okay, only one element is favorable, that is when x equal to 0, which implies x equal to 0. Look at this. When x equal to 0, what happens? When x equal to 0, it becomes 0 plus 1 equal to 1. So, you know that this is the only integer. 0 is the only integer which satisfies the above condition. So, I am going to write the element of the set V in the roster format within braces only one element 0 which satisfies the condition. So, V equal to 0 is the required set. Now, we are going to study the second method, set builder form. At first, we can discuss the definition and then can come to the example. In this method, that is in set builder form, all the elements of the set possess a single common property. That is very important. All the elements of the set has a property, and that property I am going to say as Pfx. In such a case, the set is described by, you need to write the set this way, set of all x such that Pfx hold. You get a vague idea only. We can come to the example and then come back to the definition again. Come with example 1. Write the set A, E, I, O, U in set builder form. When you are asked to write the question in the set builder form, remember the question given to you or the set given to you will be in the roster form. Within curly braces, elements are listed. You are asked to write in set builder form. The set builder form states that the elements possess a single common property. So, you need to watch carefully and find out the single property which holds among these elements. What is the property which holds here? You can say that A, E, I, O, U are the vowels in the English alphabet. So, I am going to write it in the set builder form as V is equal to, the condition is that you need to write the set in this form. V is equal to set of all x such that. Then write the property. What is the property here? Pfx. Pfx means the property. What is the property here? X is a vowel in the English alphabet. X is the vowel in the English alphabet. Okay, so this is the way you need to write a set in the set builder form. Set builder form, general form is set of all. You need to write in curly braces itself, set of all x such that Pfx. Pfx is that the single property which holds among the elements that you need to write. One more question. Example 2. Write the set 1, 2, 3, 4, 5, 6, 7, 8 and 9 in set builder form. Okay. At first, you need to closely observe the elements in the given roster form. What property you can find in this case? You can see that 1, 2, 3, 4, 5, 6, 7, 8 and 9 are all natural numbers. So, I am going to write the set in this way. V is equal to, any letter you can use. going to write the set x. The property you need to write here. Many ways are there with fourth, right? You can write as x is a natural number. X is a natural number and x is less than 10. In this way you can write, simply you can write like this: x is a natural number and x is less than 10. This is the common property which holds among the elements. Or in another ways we can write this as v is equal to set of all x such that. Look at the way I am going to write. X is an element of, this is the symbol which represents an element of. X is an element of the natural number set n. The condition is that x is less than 10. In this way also you can write. Actually this statement is the mathematical statement for the set builder form. If you can't write like this, you can write in this way also. Both are same. So in many ways you can write, but the common property which holds among these elements will be same. Okay, now we can come to the definition of set builder form again. In this method, all the elements possess a single common property, and that property you need to take as p of x. After that, what you want to do? The set is described as set of x, set of all x, such that p of x. P of x means that the property you need to write here. We can discuss some more problems based on the set builder form. Look at problem 1. Write the set A equals 3, 6, 9, 12, 15 in set builder form. Okay, at first you need to observe and find the common property. What is the common property here? Okay, you can write as x is equal to set of all x such that. You need to write the property here. What is the property? X is a multiple of 3. X is a multiple of 3 and x is less than 15. Sorry, less than or equal to 15. X is less than or equal to 15. One property you can write in this way, or one way is the representation of the set in the symbol way like this: x is a multiple of 3 and x is less than or equal to 15. Or I am going to write in much more standardized way as A equals set of all x such that. How we can write x is a multiple of 3? We can write as x is equal to 3 into n. How? N can be a natural number. N can take as a natural number and the value of n must be less than or equal to 5. Check it. X is a multiple of 3. So x can be written the way as x equal to 3n. N is a natural number. So n can take the values 1, 2, 3, 4 up to 5 only. So when n equal to 1, what will happen? 3 into 1, 3, the first element. When n equal to 2, what happens? The second element, 6. When n equal to 3, the third element, 9. When n equal to 4, the fourth element, 12. And when n equal to 5, the fifth element you will get. So this is much more standardized way of writing a set in the set builder form. Come with problem 2. Write the following set in set builder form. D equals the set 1 by 2, 2 by 5, 3 by 10, 4 by 17, 5 by 26, 6 by 37 and 7 by 50. Observe the elements and find a common property in between the elements. In all the elements, you can see that all are fraction. The numerator is, if the numerator is 1, the denominator is 2. Then the second, when the numerator is 2, the denominator is 5. Okay, I am going to represent it as D equal to the set of all x such that. X can be written in this way. Numerator is a natural number by the denominator is the square of the natural number plus 1. That is 2 can be expressed as 1 square plus 1. Actually 5 is 2 square, the square of the numerator of 4 plus 1. 10 is the square of the numerator, that is 9 plus 1. 17 is the square of the numerator 4, that is 16 plus 1. This one is the square of the numerator 5, that is 25 plus 1. This 37 is the square of the numerator 6, that is 36 plus 1. And the last one is the square of the numerator 7, that is 49 plus 1. So we can write as x is equal to, it is of the form of a fraction n by the square of the numerator n plus 1. But n is a natural number, am I right? And n can take the value up to 7 only. So n must be less than or equal to 7. Up to 7 only n can take the value. This method seems to be good for to write the set in the set builder form. Come with another question. Describe the following set in set builder form. B equals 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Closely observing, you can see a common property between the elements. All the elements are prime numbers between 50 and 100. So we can write as B is equal to set of all x such that x is a prime number. X is a prime number. But the condition is that the value of x lies between 50 and 100. So this is the common property, x is in between the elements. So these are the two ways for representing the set. The first one is the roster method, in which the elements are listed in braces with a comma in between them. And the second method, in all these set builder forms, you need to write a set of all x such that. Then write the common property. If you can write in the standardized mathematical way, that seems to be good.